Rocket engines use different cycles to produce thrust. In this video, the most common cycles are explained. The gas generator cycle is the most simple cycle. In this cycle, portions from the main fuel and oxidizer stream are fed into the preburner. In the preburner, fuel and oxidizer are burned and the hot gases are directed into the turbine. The turbine then drives the fuel and oxidizer pumps. The exhaust of the turbine is dumped overboard through a small nozzle, which also creates a small amount of thrust. The pressurized fuel and oxidizer mainstreams are let into the combustion chamber and burned. If the engine is regen cooled, the fuel flows before entering the combustion chamber around the nozzle walls. For example, the Merlin engine of the Falcon 9 uses this cycle. A more complex cycle, but similar to the gas generator cycle, is the staged combustion cycle. Here, the complete fuel stream flows into the preburner and is burned fuel-rich with a portion of the oxidizer. The gases enter the turbine, which in turn drives the pumps. The partially burned fuel out of the turbine is not dumped overboard, but instead directed into the main combustion chamber, where it is fully burned with the complete oxidizer flow. There are some variations of the cycle. For example, instead of the fuel-rich preburner, also an oxidizer-rich preburner can be used. Another subcycle is the full flow staged combustion cycle. Here, both oxidizer and fuel are directed into the fuel-rich and oxidizer-rich preburner. This is the most complex cycle with the best performance and efficiency. One advantage is that propellants are better mixed, because they are entering the combustion chamber in gaseous form. Only two companies have successfully hot-fired such an engine, namely SpaceX with its Raptor engine and Space with its Nova launcher rocket engine. The next cycle is the tap-off cycle. In principle, the cycle is really simple. Here, both fuel and oxidizer enter directly the combustion chamber and are burned. Then, a portion from the hot gas inside the combustion chamber is directed into the turbine, which drives the turbopumps. The exhaust of the turbine is dumped overboard afterwards. This type of engine does not need that many parts, but the materials of the components have to withstand really high temperatures. The Reaver engine from Firefly Aerospace and the beofre engine from Blue Origin are using this cycle. Another cycle is the expander cycle. This type of engine is regen cooled. The complete fuel stream flows along the combustion chamber and nozzle walls, heats up and expands. This expanding of the fuel is used to drive the turbines, which in turn drives the turbopumps. The expanded fuel is afterwards directed into the combustion chamber and burned with the complete oxidizer stream. In this engine design, the combustion chamber is often extended, so that the fuel gains more heat by running through the cooling pipes. This scheme presents the closed expander cycle. Another subcycle is the open expander cycle, where only a portion of the expanded fuel is used to drive the turbines and afterwards dumped overboard. An example for this type of engine with an extended combustion chamber is the Vinci engine. The last engine cycle is the electric pump-fed cycle. In this simple cycle, the oxidizer and fuel pumps are driven by an electric motor. Oxidizer and fuel are then burned in a combustion chamber. Rocket Lab's Electron rocket uses this cycle.